All right, hello and welcome to the area of a triangle tutorial. So here we're going to talk about how to find the area of a triangle using the trig methodologies that we did in class the other day. So if you remember from previous years, the area of a triangle is usually just regarded as 1/2 base times height. So it's just the base of the triangle. So if I draw a triangle here, it's just the base of it times the height of the triangle itself. Okay, so that's what we're usually dealing with. However, what happens if we're dealing with something that isn't exactly the nicest triangle to work with? So dealing with scalene triangles or isosceles triangles that you don't know what the height is. So in order to get around that, what the area function that we use, right? So area is going to equal 1/2 AB sine of C. Okay, so if you're looking at a triangle, and let's label these as angle A, B, C. And remember that the opposite is always the smaller or the lower case of the letter angle. So A is little a over here, B is opposite to little b, and C is opposite to little c. So what this is saying here is that AB are the two lengths that we need to use, and sine C is what we need to use here. There are a couple of ways to write this, though. You can also write the area of a triangle as 1/2 BC sine A, or you could also write it as 1/2 AC sine B. So if I said that it's BC sine A, I'm looking at B and C and the sine of the angle A. Or if I'm looking at AC sine B, I'm looking at AC sine of B. So there's a couple of different ways to write it. And the easiest way to remember it is that you just need two lengths. So we need two lengths and a contained angle. So we have two lengths and a contained angle. And what I like to call this is, we like to call this an angle sandwich. Okay, so in order to find out what the area of a triangle is, just remember that we need to make an angle sandwich. Okay, and you'll see an example of this coming up in a second. So let's say that I wanted you to find the area of a specific triangle. So I want to deal with this triangle right here. Might not be the best drawn triangle in the world, but we can deal with it. So let's say that this angle in here is 115 degrees, and I have 6 centimeters of length on this side and 5 centimeters of length on this side. Now it's not exactly drawn to scale, but that's okay, right? So the information here is correct. In order for us to figure out what the area of this triangle is, so we'd say that the area is simply, let's say that this is A or B or C. It doesn't matter to us. It's just two lengths and the contained angle in between it. Okay? You can label this all you want. You can say that this is angle A, little a. You can say that this is B and this is little b. And you could say that this is angle C and little c. And then we'd find out that we're actually using areas 1/2 of B and C sine of A. But if you just remember that we need two lengths on either side and the angle in between to make an angle sandwich, it's a little bit easier that way. So now that we know which lengths we're using and what angle we're using, we're going to say 1/2. Let's fill in the actual length. So we know that we have length of 6 centimeters. We know that we have a 5 centimeters. And we know that we have the sine of 115 degrees. So let's actually plug this into our calculator first. So we're going to say 6 times 5 times 115 sine, right? You're going to put this in your calculator a little bit different. So if you have any questions about how to use your TI-84, you're going to have to come see me. Unfortunately, my trial for the TI-84 has run out, so I need to get another one here soon. So I know that I'm going to have 1/2 of 27 oops, my calculator ran away from me. Here it is, 1/2 of 27.189 And I'm having some rounding issues here, right? Because it's actually 27.1892336110995, etc. So that's why we want to make sure that we're putting that sine 115 in all together. So that way we're actually getting the most accurate answer we can. So right here when I'm halving this, it's not exactly precise. So we're going to divide that by 2, and we're going to find out that it's, let's say that's 13.59. So this is 13.59. And don't forget the units here. This is, we were dealing with centimeters, so this here is actually going to be centimeters squared. Okay, so we know that the area of this triangle is 13.59 centimeters squared. Let's look at another one where there's a couple of different angles being given to you, so that way we can identify what we actually need. So if I have a triangle, looks like this. Again, they're not always drawn to scale for me, so I'm going to say that this is 53 degrees, this is 31 degrees, we have 6.9 meters, and we also have 10.7, whoops, that's supposed to be a 7, 10.7 meters. Okay, so what type of angle, what angle do we need to use here, right? So I have a length here, I have a length here. Usually it's my two lengths and a contained angle, but we don't have this contained angle here. With this question, what we have to realize is that all three angles of a triangle must equal 180 degrees. So here I have two angles. So I know that 53 plus 31 plus x, oops, will have to equal 180. So in order for me to figure that out, I have to add these two together. So I'll know that x is equal to 180 minus 84. So I know that this angle inside here is going to be 96 degrees. Okay, so now that I can label that in over here and I say 96 degrees, all of the total angles in here now will equal 180 degrees. So this is just a secondary step. This should be a review from previous years, but if it's not and you need some more work on that, please come see me. That is not a problem. So what we do now is we finally have those two lengths and that contained angle that we need in order to figure out the area. So now we know that the area is equal to 1/2 of, let's say 6.9 centimeters times 10.7 centimeters times the sine of 96 degrees. So we can plug all this into our calculator. So we'll say that we'll have 6.9 times 10.7 times, I have to put my angles in first here and then hit sine. Yours is a little bit different. Let's say what that equals. So that will equal 73.42, but we also did not account for that 1/2 in the front, so we have to divide that by 2. And our final answer here will be 36.71 centimeters squared. Right? Because centimeters squared is talking about area. So in area, we're always squaring our units. Right? So this whole entire region here is going to be giving us 36.71 centimeters squared. Okay. There is one separate way to do this. There's one different way to do this that we're interested in, and that is if we're given the total area of a triangle. So let's say that this angle here, or sorry, this triangle here, with values of 78 degrees, 14 centimeters over here, and x centimeters over here. And let's say that the area is equal to 150 centimeters squared. So we're given different pieces of information, but here we're going to use the exact same formula as what we were before. Because I have two lengths here, and I also have a contained angle. So we're going to make that angle sandwich. So we know that we have our contained angle between them, and we know we have to make an angle sandwich. So here we're going to have set the area itself equal to 150 after I initially set this up. So we have 1/2 of 14 centimeters times x times the sine of 78 degrees. So now I know that my area is equal to 150 centimeters, so I can write that in, centimeters squared. It's equal to 1/2 of 14 times x times sine of 78. Well, now we need to isolate for x, so in order to do that we have to manipulate a couple of things. This 1/2 means that I'm going to have to multiply the other side by 2, and the rest I'm going to have to divide by. So I'm going to say that 150 times 2 all over 14 times the sine of 78 will allow me to solve for my x. So I know that 300 over 14 times sine of 78 will equal x. So I go over to my calculator, I put this in, I say 300 divided by, make sure you put a bracket here because we need to multiply 14 by sine of 78. So 14 times 78 sine, and that will give me 21.94 or 90. So I know that my x is equal to 21.90 centimeters. 21.9. Oh, actually, let's call that 9.1. Sorry about that. That should be a 9.1 because we're rounding to 2 decimal places here. So 21.91 centimeters. And to double check, make sure that it works. So now that we know that this is 21.91, and you can work backwards, right? So you can say, well, I have 2 lengths. I have a length here, and I have a length here, and I have the angle between. Plug that into your area formula, all of these together, and it should give you 150 centimeters squared. Okay, so that's it for the area of a triangle. Take a look in our Google Doc for more practice areas for this if you would like to do some. Thank you for watching.